Good day, class. Welcome to another METI 14 video lecture. For today, we will be discussing Central Composite Design or CCD. So let's just recall our last lesson. So we did RSM and specifically the method of steepest ascent. So first we did step one, which was to choose a region for initial investigation. Then we fitted a first order mathematical model. Then we investigated the model and checked for lack of fit, and if the model uh, adequately fitted the data, then we can perform the method of steepest ascent. Then after method of steepest ascent, we observe the response, and if there is uh, a discrepancy in the observed response, or kumbaga the model failed to fit or the model broke down, then we iterated back to step one and did the process again. So in our last lecture, we stopped here in step two, no? Or no, I mean in step three when we checked for the lack of fit. If there is if the data does not adequately or if the model does not adequately fit the data, then we need to perform a central composite design. So if you remember our lesson, um, we we showed that there is indeed a lack of it now, because if you look at here, the computed critical value is, or the computed F value is greater than the critical F value, which indicates that uh, the LOF or lack of fit is indeed significant, and if it's significant, then meaning the model does not fully fit the data we have. So now we need to upgrade it to a central composite design. And for central composite design, this is usually done so that, or this is done so that we can create a second order or a quadratic model. So take note, when we were doing the method of steepest ascent, we were only dealing with linear models now. So this time, gagawa tayo ng second order quadratic second order quadratic model. Okay? So for the CCD, bukod dun sa factorial points and the center point runs. So again, factorial points here is yung original 2 to the k settings, yung mga low and high settings, that's the minus 1 and the plus 1 coded settings. Then this center points run, 10 center point runs where the 0 coded settings. And now we add what we call as star points. So star points is defined by an alpha value. No? So the alpha value here, take note, is different from the alpha for level of significance. No? So usually we have alpha is equal to 0.05, but this alpha value for star points is widely different. No? So I'll show it later on. So to perform CCD using star points, we follow these four steps now. So first we code the levels as -1, +1, and 0. So we already did this now when we did the initial investigation and the RSM. Excuse me. Now we calculate, the next step is to calculate alpha according to the number of factors. Then after calculating the alpha, we list down the coded star point settings. Then we convert those coded star point settings into a actual or a natural setting. So we start with calculating alpha. So alpha is just the distance of the start point from the center point in coded units. So here we have a table that is a guide in choosing our alpha value versus yung number of factors na meron tayo. So if it's 2, we have 1.4142. We have 5 factors, it's 2.3784. So these alpha values can be computed using this formula now. 2 to the k over 4, where k here is our number of factors. So we have For the example we did was we were trying to excuse me, we were trying to investigate how yield was affected by temperature and time. So time and temperature, so that's two factors. So we have 2 raised to 2 over 4. So that's 2 raised to 1 half, or just the square root of 2, and square root of 2 is equal to 1.4142. Okay, so if you look again, for example we have 4 factors, so that's 2 raised to 4 over 4 is 2 raised to 1, and 2 raised to 1 is equal to 2. Okay, so you can use this um, equation so that you can solve for the alpha factor or the alpha value. Excuse me. So here, this is an illustration of how uh, the coded or the how the design of experiment would look like now. So if you look at the square, the corners of the square represent your factorial points now, or this is the usual 2 to the k combinations. So if you look here, we have this is plus 1, meaning both factors are set to high setting, while this point is minus 1, where both factors is set to low settings. Okay, and here we have x1 is plus 1 or high setting, while x2 is at low setting, and this is vice versa. Okay, so apart from this, when we did MSA, so this is just the usual 2 to the k factorial design. Then when we did RSM and MSA, we added the center point runs. So center point runs were coded as 0, so that's the center value here. So that's, we have x1 is 0 and x2 is also 0, so it's located at the origin. Now we add several other points, no? So the number of star point settings will just, the additional star point settings we will add is just equal to 2 times k, or 2 times the number of factors. So if we have 2 factors, so that's 2 times 2 is equal to 4, so we add 4 additional star point settings. So here, the star point settings is a combination of 0 and a plus or minus alpha. Right? So we have, for example, this star point setting here is when x1 is plus alpha, while x2 is 0. Here we have x1 is 0 and your x2 is plus alpha. Okay, so and we can do it again for these two other points now. Okay, so when we do that, we can now complete the coded settings now. So this is a table of your coded settings. So this is just all the combinations of zeros and plus or minus alpha. Okay, so we have 0, 1.414, 0, minus 1.414, 1.414, 0, and minus 1.414, 0. So take note, this the arrangement here is arbitrary, no? But this is just all the possible combinations. Okay. So now that we have our coded settings, coded star settings or star points, now we need to convert this into actual or natural settings. So to convert it, we use again the formula now. So that's x here is our coded setting, x prime is our natural setting, CP is the center point setting, while HS here is the high point setting. Okay, so if we rearrange this formula, we should be able to get x prime is equal to x multiplied by hs minus cp plus cp. Okay, so let's just look back at the data we have now. So let me navigate back. So if you remember, um, we were doing MSA and we actually ended with the 11th run now. So if you look at the 11th run, the yield actually dropped from 80.3 to 79.2, meaning the model did not, um, or the model broke down in a sense now. So when the model breaks down, we go back to